Alright, so the next topic is the acceleration due to gravity and free fall. They're actually the same thing. Galileo is probably most famous for this experiment, and it's actually a thought experiment. Um, he said if you go up to the top of a very tall building and you take two objects that had the exact same inertia. Now, inertia is a topic we haven't really talked about. If you let them go, well, inertia is basically mass. If you let them go, they'll both hit at the Earth at the same time. Okay? What Galileo was talking about was that everything that is dropped like that experiences the exact same acceleration, the exact same change in its velocity. Okay? And that acceleration, because it's the exact same value regardless of where you are on the surface of the Earth, because it's the same, we give it a name, the acceleration due to gravity. Now, graphically, the acceleration due to gravity is equal to a value we call g. Okay, so when you see a lowercase g, we're referring to the acceleration due to gravity. Common misconception, and I'm guilty of this. It's not a misconception for me, but I just screw up the vocabulary. G is not referring to gravity itself. It's referring to the acceleration due to gravity. Now, that value of 4g near the surface of the Earth turns out to be negative 9.8 meters per second, which, if you remember right, we express this way. Okay? That is the acceleration due to gravity near the surface of the Earth. It turns out when we talk about the modern forces, the modern look at forces, that value g, the acceleration due to gravity, doesn't hold true the higher up you go from the surface of the Earth, or the deeper you go into the Earth. Okay, but anyway, for now we're going to treat it as 9.8, negative 9.8. Remember, negative meaning that it's, in this case, going down. We all know that when we release an object, it falls towards the Earth. Okay? So that's the acceleration due to gravity. For most cases in my class, we can make an approximation. Never on a test, anytime on homework though. We can make this approximation for the acceleration due to gravity. Okay? Instead of 9.8, we can simply round it up to 10. It's really, if we round it up to 10, it makes the math go much faster, and it seems a lot simpler for people. Okay, that's the acceleration due to gravity. The word free fall is referring to an object that isn't supported by something else. It's not resting on a table. It's not resting or being held by a string or anything like that. That object is in free fall if all it experiences is the force of gravity. Now, we haven't talked about the force of gravity, but we're all familiar with the idea. Objects are being pulled down towards the Earth. If there's nothing else holding that object up, we call that object in free fall. It's being pulled and being accelerated at the acceleration due to gravity at 9.8 meters per second. Okay, so free fall by definition means that an object has no support, it's not being held up by anything, and is falling towards the Earth at an acceleration of negative 9.8 meters per second. Okay, that's free fall. That's why it's basically the acceleration due to gravity. Free fall is referring to the absence of forces, absence of supports, if you will. The acceleration due to gravity is just g, the 9.8 meters per second. Okay, cool. That is acceleration due to gravity.